Hey Mom. What's for dinner? Chicken stew and fried veggies. Stop. Don't touch it. Wash your hands first. I wonder how this soap pump works. Hey Mom. How does the soap pump work? Let me go wash my hands first. I gotta look it up real quick.
Welcome to my video, where I will explain the fluid mechanics of a soap pump. When I push the nozzle head down, the soap come out from the top. Counterintuitive, right? First, we need to understand how the pump is set up. The dip tube is at the very bottom in contact with the liquid soap. At the top of the dip tube sits a solid ball. This solid ball is kept in place with the help of a housing. The spring sits on top of the housing. Above the spring is a piston which pushes down, and at its center is another solid ball acting as a valve. And on top of all of this sits the nozzle head. When we push the nozzle head down, we apply a force, F over a cross-sectional area A, creating pressure P according to Pascal's law, which states a pressure change in one part is transmitted without loss to every portion of the fluid and the container walls. So when the nozzle is pushed downward, so is the liquid, creating a pressure gradient, where pressure is high outside the tube than inside. This creates a force upward into the tube, causing the liquid at the bottom of the container to be sucked into the dip tube and flowing into the check valve. Let's look at the fluid mechanics behind a liquid soap pump. When the piston moves a small stroke distance, delta x, it displaces a volume equal to the piston, area A1 times delta x. The mass delivered per stroke is density, rho times that volume, so delta m equals rho A1 delta x. During motion, mass flow in equals mass flow out. That's the continuity equation. Rho A1 V1 equals rho A2 V2, giving V2 equals A1 over A2 times V1. Using typical dimensions, A1 over A2 is about 25. If the piston speed is 0.02 meters per second, the outlet speed becomes 0.5 meters per second. From Bernoulli's principle, that velocity change corresponds to a pressure of roughly 115 pascals. By Pascal's law, the force on the piston is pressure times area, about 0.04 newtons ideally, though real pumps need more due to friction. So a gentle push of your hand converts small pressure into fast, directed flow, a perfect example of continuity, Pascal's, and Bernoulli's laws in action.
So, to answer your question as to how the soap pump works, is when you press the pump, you apply pressure to the fluid, and check valves make sure it flows only one way, up to your hands. Ah, I see.